Learning module of Financial Engineering Part. Introduction to term efficiency. Relation between energy consumption and productivity. The amount of produced goods per unit of energy consumed per unit of time. Ratio between amount of units of produced goods and the amount of consumed raw materials per unit of energy consumed per month or per day or per hour. Ratio between amount of units of produced goods and the amount of labor spent per unit of energy consumed per month or per day or per hour. As basic principle, all external factors affecting the production level must be considered together as parameter, while setting the ratio equations to be used as metrics in order to measure the efficiency. In other words, one has to notice in how many minutes, days, months he is able to produce goods. However, he has to be aware that how much amount of resources he has to consume in order to create those goods either. These are two important external factors which affect the productivity ability. There are two important consumption potentials to use smartly in order to produce more while spending less. Hence that indicators that will be designed so as to measure efficiency must be redesigned in such a way. As it is mentioned, time and energy consumption should be reckoned together as parameters while beholding efficient production. In other words, machinery capacity and energy consumption rates of machines have to be taken into account at the same time. Correspondingly, new investments that are for increase in efficiency have to be able to decrease average energy consumption rates of machines per unit of time as well as to increase machinery capacity. So, an investment can be said as smart investment when it is capable of increasing the efficiency in both aspects, energy and time consumption. Their performances should be evaluated according to these two parameters together. In the following figure, that necessity is explained mathematically. Know how to measure efficiency and productivity rates of energy efficiency and renewable energy investments. Financial provision of the above definition. Change in time and energy consumption and change in amount of produced goods must be compared under same unit of dynamics. Therefore, time and energy consumption parameters must be combined on same mathematical expression. Unit value must be selected for energy consumption per defined unit of time. Consequently, an increase in amount of goods produced must be achieved per that much unit of consumed energy per that amount of unit of time. That is the expectation from investment to accomplish so as to be said as feasible. Consequently, financial results of that parametric observation are needed to be measured. Change in profitability, thereby exact saving value due to any investment can be monitored for feasibility analysis. Question: what does it define to measure the quality value of an energy? Answer: maximum potential energy work that can be acquired by using the energy's resource with the most efficient alternative. Up to now, as key feature, it can be said that consumption of energy per unit of time will be new basis of metric. Then question would appear to be answered. How to measure the consumption? Generally, quantitative value of energy can be determined classically. But how about the qualitative value of the energy? Each energy resource item has a quality value, that means its exergy value. Energy has quality value beside its quantity, and this value shows the work potential of energy. The higher quality value means the higher possible work output that can be procured. Hence, how much percent of that work potential, of that quality of an energy resource item is achieved to convert as work output must be taken into account while measuring the efficiency. Exergy value of any energy resource item is the exact potential gain that can be acquired by the power of efficiency investments. Here is a list of parameters to calculate energy efficiency as a ratio between used energy resource and energy requirement in aspect of exergy. Ratio between energy resources exergy value and production lines exergy requirement value would give the how much amount of energy work potential of any resource could be utilized while production. Any investment that can be set efficient must be capable of increasing that value. However, in order to make a complete analysis, qualitative and quantitative values of energy consumption must be considered together. In order to create a ratio formula aiming to compare consumed energy and required energy both in aspect of quality and quantity, there must be a formula. Smart efficiency and productivity determination approaches. Ratio of amount of units of produced goods to amount of inputs per unit of consumed energy per unit of production time. Ratio of exergy requirement of produced goods to amount of inputs per exergy amount of consumed energy per unit of production time. The calculable form of this modified indicator is mathematically expressed as shown in slide as a metric that is to measure the performance of investments. Obviously, financial provision of that saving calculation module is necessary to develop feasibility tables and make necessary comparisons about profitability, power of an energy efficiency, or renewable energy investment. The exact saving calculation module to be used in feasibility analysis is as follows. Financial engineering process so as to develop feasibility analysis methodology, ARR, annual rate of return. To make detailed analysis about feasibility of an investment, some measurements have to be developed. By power of these measurements, it will be easy to analyze performance of an investment. It's the way to model correlations between energy savings and financial results. It must be noticed that while modeling feasibility tables, two main phases have to be completed. First is to calculate the saving exactly and clearly. Up to this chapter, it was explained how to model calculation content mathematically of the saving value. In this chapter, the second phase will be represented. Critical financial instruments will be introduced. First, one is annual rate of return, that is ratio between capital cost and average annual saving value of investments. Break-even point. Payback period is the length of time that is required to equalize capital cost and total annual savings values. Obviously, it can be expressed that the shorter the payback period, the more preferable the investment. For energy investments, managers have to decide whether it is reasonable to invest alternative energy system or re-engineering system to procure electricity instead of already existing conventional system. It must be determined if it's worthwhile to purchase electricity from a newly designed system or not. An example is given in slide. At that point, some parameters and its numerical values are important while making an analytical comparison. Break-even point. Due to these values, minimum number of power purchasing hours per year has to be calculated that will make diesel engine feasible. Now it's time to equate first mathematical expression to the second one to find minimum number of power requirement hours which will make investment reasonable. As annual total operating hours are approximately 8,000 hours, it seems feasible alternatively to prefer diesel engine implementation. Roundly, a plant sample that is analyzed in example requires power more than 11 hours per day, subjected investment would be feasible. This threshold value is called break-even point. That comparison of critical point may be shown on graph. Net present value method. This method is related about a factor which shows the reduction effect on value of the savings. Additionally, it must be noted that for year 0, at the beginning of time of the project, interest rate is defined as 1.0. Total net value of project has to be considered so as to monitor the current profitability. It's calculated by summing all costs and net total savings related to investment. NPV is expected to be more positive as possible. NPV is a significant pathfinder so as to discern feasibility level of a project for mid and long term. An example table is given to show the calculation steps and tables of NPV analytically. In table, capital cost and net annual savings values for 6 years of 3 candidate project alternatives are given. It can be seen that discount factors are unaccounted while deducting annual savings. However, While calculating NPV, capital costs are subtracted from discounted annual savings values. In next figure, NPV for 6 years span is calculated for each project and is tabled. Profitability index. Mathematically, NPV cannot be an enough metric for projects having different capital costs. Hence, for these samples, developing a ratio between discounted net annual savings and capital cost would be more effective instead of subtraction. Thus, performances of prospect investments according to financial results and capital costs can be standardized. That formula is called as profitability index. According to index, previous example can be derived again. Profitability index values for each project are calculated. Inflation. Quantitatively, if inflation rate is 10%, purchasing power of £100 will be indeed equal to £90.91 as real price. Mathematically, that loss can be expressed and calculated as in the following. The IRR indicator can be expressed as discount rate that will vanish the NPV of a project. The decision mechanism is modeled on basis of finding the exact discount factor of which yearly net return, which is subtraction of total net annual savings from capital costs, becomes zero for such an amount of time. Generally, the rate of decrease in value of money by the time is defined as inflation. Quantitatively, if inflation rate is 10%, purchasing power of £100 would be indeed equal to £90.91 as real price. Feasibility table. To make a developed feasibility analysis, now it would be meaningful to go through a sample. As example, a company thinks to invest in new energy technology that costs £30,000. More, it's estimated that the technology would provide a £30,000 annual saving for the first year. Then this value would escalate by 5% for each year and the project life would be 4 years. Information about variable costs and financial factors are as shown in the slide. According to this information, primarily net savings must be calculated by subtracting cost items from estimated savings values with the consideration of escalation rates. First step is to develop a table concerning that process. The next and the final step is to present net real value gains by taking into account of rate of interest and inflation factor. Introduction to energy efficiency investments rentability. Critical parameters affecting the profitability and payback period of time of energy efficiency investments. Facility layouts, locations of machines, process flow inside factories, location of substations and supplies. Now it's time to explain information about energy efficiency investments profitability. Critical parameters that may affect the profitability and payback period of time of energy efficiency investments are facility layouts, locations of machines, process flow inside factories, location of substations and supplies. Engineering optimization focused on industrial aspects. Productivity can be increased on focus of energy by the power of customized investment. More user-friendly, so easy to apply. Factories' all needs may be ignored whether a customization is not applied. Increase in productivity, so increase in efficiency performance can be maximized, thus financial results will be optimized. It must be noted that any energy efficiency investment project must be customized according to factory's needs instead of applying the catalog models directly. Facility layout is the most influential factor and all technical details firstly have to be designed due to placements inside the factory. Otherwise, production line can be affected adversely. Process flow of production must not be blocked by new equipment or machinery extensions which are located to increase energy efficiency. If that is not taken into consideration, productivity may be reduced by mistake. Engineering optimization focused on industrial aspects. As technological and development level of an investment is increased, its capital cost will be expected to rise also. Achievement to utilize more work output from potential exergy value of used resources will be increased. Managers must create a balance between rising costs and consequently increase saving values. Generally, it must be known that as long as any investment is technologically developed more and more, its capital and operational costs will be expected to rise consequently. However, its long-term outcome would increase very likely. Hence, there must be balance between costs and benefits. It should be decided according to goals at managerial level at corporate objectives. Senior management of companies must analyze expectations about growth targets and profitability goals. Forecasted sales ratio can be the main indicator while giving that decision. Noteworthy indicators while implementing an energy efficiency investment. Its ability to be improved. Software components must be flexible according to new optimization decisions through changing production planning strategies. Automation systems have to be capable of modifying with new sensors and control mechanisms such as thermocouples and valves. Communication systems that provide information and control flows between machinery pod and software applications should be in a form of being easily changeable. Technological development level of any investment must be considered while implementing a project. It must be improvable according to new technological advancements that will probably occur along project life. Otherwise, some opportunities might be missed so as to increase efficiency much more. If such a scenario exists, unpredictable opportunity costs may arise. Therefore, an investment must be technologically adaptive to new improvements. Its software components must be flexible according to new optimization decisions through changing production planning strategies. Introduction to renewable energy investments rentability. Critical parameters affecting the profitability and payback period of time of renewable energy application investments. They are designed for certain average values of ideal conditions. Humidity, precipitation rate, and other weather conditions are entered values after making some estimation while modeling designs. Average wind flow rate, wind current characteristics, wind directions, precipitation rate, and other critical parameters are considered. Some assumptions are made for these values while modeling wind turbines and its components, and they affect the conversion rate of renewable energy into electric or heat directly. Renewable energy technologies are first designed for ideal conditions. For instance, photovoltaic panels are designed for certain average values of sunshine hours. Surface area and content of each cell of solar systems are modeled for some assumptions. Some critical characteristics of any flat land are predetermined. Moreover, humidity, precipitation rate, and other weather conditions are entered values after making some estimation while modeling designs. Same approach is followed also for other renewable technologies such as wind turbines, heat pumps, etc. Hence, while putting an investment into practice, making an implementation, these conditions must be noticed as constraints. Engineering optimization focused on industrial aspects. True approach for renewable energy technologies implementation. Renewable energy investments have to be started to be applied with optimally fine-tuned values to minimize the payback period. Renewable energy technologies must be customized according to needs and constraints of the investment region. Payback periods and efficiency rates given at catalog list are measured for assumed ideal conditions. In order to acquire these values of renewable energy technologies, technical designs have to be remodeled. Engineering optimization focused on financial aspects. Some factor samples related to nature which affect payback period of a renewable energy implementation: wind flow, solar regime, humidity rate, soil temperature, carbon content of an industrial waste to be evaluated as resource to biomass. Whether a capacity of a renewable energy is increased, consequently investment and operational costs would be expected to increase also. For instance, wind farms have to choose as large as possible regarding to weather conditions, and maximum amount of wind turbines have to be placed in these areas while considering optimum distance that has to be maintained between turbines. That is same also for solar panels placement to solar fields. Thereby, converted amount of electricity will increase as these capacity amounts are increased. However, operational and capital cost of investments would be expected to rise obviously if such an action is taken. Therefore, a balance must be developed between benefits and costs of any investment. possible investment financial plans by using funds and credits. 3 main topics which are necessary to prepare for application to governmental and non-profit organizations supported funds. Technical description of energy efficiency or renewable energy technology. Explanation of engineering implementation steps so as to perform the installation of technology. Financial feasibility plan.